Hello, hello.
Good morning, Professor.
Morning, thank you. Hello, Nikaya. Hello, Yasmin. Hello, Molly. Hello, Alyssa. Good morning, Asia. Hello, Jennifer. Hello, Antonio. Hello.
Good morning, Professor.
Good morning. Thank you. Hello. I think I was. Oh, good morning. Yes, thank you. Hello, and hello, Dorina. Good morning, Molly. Good morning, Luna. I'm doing. If I'm doing. Hello, Jean Pierre. Who else? Catherine. Hello. Rani, good morning. Okay, this is working, I think. Okay, I got you can hear me. Oh, and we're yes, yes. Good morning. Okay. Oh, yeah. Oh, yes. Hold on a second. Okay, yes. Good morning. Good morning. Just got a question in the chat. Very fair question. That I'll just address. I won't. Right. I did not intend for to be due yet today. Like this class, you guys are no one is you guys are very much on top of things. Like I got a ton of train of thoughts from people, like homework number 3, and I believe turned it back. I mean, but no, nobody was responsible. If homework 4 means average acceleration, and I'll check I think Google Classroom was cleaned up, and I think it says what it's supposed to say. But absolutely right. To answer the first question in the chat, you were not for today. If homework 4 means average acceleration. Good morning. Good morning. Yes. I hope that. No, I think you guys are very on top of the homework, which is great. I mean, it feels like I barely ever see you. It feels like, or it feels like it's been forever since we've done any physics. But that's because it's been forever since we've done any physics. No, I think at most what I wanted you to have done for today was a train of thought. And if you haven't, I'm not looking at it right now at the moment, but if you haven't done it yet, there's still, please do it. We are going to hopefully discuss it today. We're going to get, it doesn't matter. You can and still should still do it for points. I believe anything you have done, you've gotten back. And that also includes, you should let me know, unless you handed in something like about a couple of hours, which again is fine, but then you wouldn't have gotten it back yet. All the assignments called a game, hopefully they're becoming more clear to you how they work. I mean, I think I explained it last time I met, but I've gotten a lot from you guys, like in principle, each next turn, I believe today's turn 5 or something like principle, just do it a half hour right after class, just jot down a thing for today's class. So that's why there will be time. And then any of the game ones that don't have special numbers, but just have special names, you can do at any time. I'm letting someone else in. I've gotten some in from people, which is great, but if you don't turn one in, that's totally fine, or you turn it in later, blah, blah, blah. So no, I think you guys are very on top of the homework. And we're going to keep talking. You will have more soon, but you're now going to get a little break. Maybe this is what I meant. We're going to keep going over the homework today. But we're going to start catching up with ourselves. That is, I hope to get to train of thought, talking about it and showing you the purpose of it today. But first, we're still going to finish going over. Tell me if I'm wrong, but I believe I probably said something about an answer, and I commented about the answer, but I don't think that I have properly gone over the problem called hill figure, like the up and down hill. In other words, the first of the problem number 4, and this is what we're going to turn to in a minute. I don't know why I'm being so vague. Like I'm going to turn in a second to average speed. That's what I believe was the while. I believe we've all gotten it back, hopefully. But we haven't finished going over, and I want to go over problem number 4 on that sheet, which is the hill figure problem. Like, unless I'm wrong, we have not said things, we haven't done it. And last but also, someone maybe I'm actually thank you. I think that was good. Maybe not. Maybe it's on my side. Is anybody else hear the noise? Okay. Okay. Um, sorry about that. If that was all right. All right. So I believe we're about to turn to, and I will on the board. We're assuming you can see the board. We're about to turn to this. And I believe, and again, tell me if I'm. Oh, sorry. Oh, confusing two problems. Sorry. Is it I don't remember, is it in this problem, is it miles per hour, kilometers per hour? I don't remember. Could someone tell me? Let me back up. This problem, this is what we're up to, right? I mean, am I correct? I believe I've said the answer and stuff, but we haven't like actually talked about it, talked it through. Am I correct? For 50 points of class participation, blah, blah, blah. Does someone want to give me a thumbs up? Could someone give me a thumb?
It's just problem 2, I think.
Oh, it's problem 2. Oh, because the first thing is all called warm-ups. Okay, thank you.
Yes.
Very helpful. All right, thank you. Someone's paying attention. Thank you.
And it is miles per hour.
And it's miles. Thank you very much. See, that's a million points right there. Seriously. Wait, so it's problem 2 and it's miles per hour. Thank you. So now I feel like someone's in the class. I did not. But seriously, that's it. Okay. Yes, thank you. Okay. Oh, except of course I'm an idiot because I mean to say this. It doesn't actually change anything, but I mean to say this. Okay. So and that was Luna, right? That was Luna who just okay, thank you. All right. So to Luna and everybody, so this is where I believe this is where we are in the curriculum. This is a study in average speed. Now let me also, because I haven't seen you guys in a while, like, and I think we're about getting into the curriculum now. Like, I mean, in a way, like we've been setting up definitions and stuff like that. I recall that when we all last met, we actually had gotten far enough that we established a concept called average velocity, which is displacement over time. And that was a precise enough concept that we actually made up symbols for it and turned it into an equation. And I do want to blast off from equation land. I mean, I do want to stay in equation land and give us more equations to start, making this look more mathematical. But I think it's important, like to get warmed up with these equations, even before we get to velocity and V bar and all that. This is just here about average speed, right? This problem says we go up some hill at an average speed of 40 miles per hour, average speed, meaning if the hill is 40 miles long, then it took us an hour to do that. Or if it's 20 miles long, then it took us a half hour to do that, etc. Then we come down the same hill at 60 miles per hour, right? This is the problem on the sheet. And it asks us, the question of the problem is, Now, the question asks, if you go up that hill at 40 and you come down that hill at 60, for the total round trip, for the total distance that you just covered, I mean, you went up plus you went down, what's your average speed for that total round trip, right? And it does seem like a straightforward question. It is meant to be simple. Although, as I mentioned, I mean, getting the right answer may be not quite as easy as it is simple. The one thing is, whether this is, it's not meant to be a trick question, but there is something I think a little bit tricky about it. The one thing about this question is it's not meant to be unfair. It's not meant to be pointlessly tricky. That is, this question comes out of the one and only fact we have in the curriculum thus far, like at the point where we get this. The only thing we know at this point is like, I want to be very, I want to be very clear about this. Like, I think I said, or stop me if I haven't, triple equal sign means definition, equal by definition, right? So this is not a discovery from some experiment. It's not a discovery in a lab. Therefore, it could never be undiscovered or disproven in a lab. We're just saying that what we mean by average speed for all time, what we mean by average speed is how far you get per how much time traveled. So if we want to know the round trip average speed, for this situation, like, I mean, to cut to the chase, since I've already seen your homework and gotten it back and stuff, like, I don't want to like play games. Like, it's very reasonable to think that the answer to this is 50. Like, this is the question: what's the round trip average speed if you go up at 40 and you come down at 60? It's very easy to think that or it's very tempting to believe that the round trip average speed should be 50, since 40 plus 60 divided by 2 equals 50. Like, the average of 40 and 60 is 50. But the thing that this problem is designed to point out right from the get-go is, it may be the case that sometimes in order to calculate average speed, we will want to or be able to average some speeds. Like, it might be the case that sometimes we'll get away with averaging speeds in order to get an average speed, but that is like getting away with crossing the street without looking both ways before oncoming traffic. Like, it's going to turn out that we can get away with that, but there's no reason to assume that that would always work. And there's no reason to assume that it's meaningful or correct to average speeds in order to get an average speed, because the definition of average speed is not the average of speeds. The definition of average speed is total distance over total time. And I'm going to say, like, and if this were an exam question or something like that, even if I didn't know if I wrote this down as step 1 of solving this problem, that step would be correct. That would be correct and get me points, even if I'm not done with the problem yet, and even if I don't have an answer yet. If I write this down first, I will get points, even if I'm not done and haven't gotten an answer yet. The reason a lot of people would not write this down, or the reason a lot of people will, the reason a lot of people will not write this down, and the reason a lot of people will jump to saying the average speed is 50 because the average of 40 and 60. And by the way, that's like not the right answer, just to be clear. Sorry, the right answer to this problem is not 50. It feels like it should be sometimes to some people. It did to me, but it's not 50. And I also know that a lot of people in the class know it's not 50. So I'm not trying to hold anybody in suspense or call anybody out. Like, I thought it was 50 when I first looked at the problem, but it's not 50. But that's not even the issue. The issue is, like, what if you got this on an exam? Like, how would you know not to fall into that trap or something? And the first way you would want to not fall into the trap of thinking it's 50 is, when in doubt, always use definitions and always trust them, because they're always true. Other things are sometimes true, but definitions are always true. So the first thing I'd write down in an exam is this. This would start getting me in the right direction. But the reason a lot of us wouldn't write this down is because, and the reason we would jump and make up this other method of like averaging speeds, is because we're actually smarter than we let on. And deep in the back of our brains, we don't want to write this down because our brain's already anticipating that if we write this down, then the next step is to plug in numbers and solve. And the thing is, our brain already knows that we don't have distance. Like, we're looking for average speed, but our brain was going to go, wait a second, I don't even know how high the hill is. Like, Yaverbaum didn't tell us, which is true. Like the problem doesn't tell you how high the hill is. And I don't know how high I go up, but whatever it is the same as I go down. So I don't know two important facts. I don't know the up distance. I don't know the down distance. And if I'm looking for speeds, I certainly don't know the times then. I mean, if I don't know the distance. So the reason a lot of people wouldn't want to write this down or think it's a trick question or something is because they think, well, I could write that, but it's not going to get me anywhere. Like I don't have that information yet. The true answer is we have to find that information or do something about that. This is right no matter what. And to go further, I'm saying, I'm just saying so far, note that average speed does not equal the average of speeds. Also, just as a side note, I feel defensive about this because I'm trying to sell you physics and I want you to like it. So I also want to point out, if I'm making a point here saying don't average speeds in order to get average speed, I'm not trying to say physics is trying to mess you up with the words. There is a reason it's called average speed, and we're going to see that soon. Average speed is, in fact, it is an average. There is a reason we call it that. But the fact is there's more than one ways in math to compute an average. Average always means the same thing, but there's more than one ways to compute one. As you know, if you've ever argued with your teacher over why you got a grade that you got at the end of the class, like there's more than one ways to do an average, even though they're all supposed to mean the same idea. So you're going to see why this like does work out, and average speed is an average, but don't just add up and divide things to get it. So what should we do here? Okay, like I'm trying to stress here because this is what a lot of people do on exams is they'll write something down that they think is relevant and then they try to make it true into a true right answer. The real thing you should always do, at least in physics exams or when you're doing physics, is you always want to start with what's true and then try to make it relevant. And don't over psych yourself. Don't psych yourself in advance. Like in other words, I'm saying here, we write down average speed equals distance over time. Okay, we say that. Then we say to ourselves, oh crap, I don't know the distance. Okay, now we have to deal with that fact. Like we don't know the distance, so we're gonna have to do something. But we don't want to take back the fact that average speed equals distance over time. Like it's still a correct statement. We don't want to like write, cross it out of the exam or erase it or something, or go on some different tack. It's still true. But what do we do about the fact that we don't have the distance here? I mentioned this last time. We actually have amazing options. If it's as simple as we just need distance over time, but we don't know the distance, assume that the problem is not flawed. Like assume that the problem is solvable. That makes a big difference because once you assume the problem's solvable, I think we said this last time, it means if you're not given the size of the hill, then your answer must not depend on the size of the hill. Like, I can't say it any simpler. Like, if this problem is solvable without the size of the hill, then it must be solvable without the size of the hill, which means that whatever the answer is must be true for any given size you pick. So one thing we can, okay, so we're assuming that here in this case, it must be because this is the situation. That means I could pick any hill distance I want, get an answer, and the answer will be true regardless of what hill distance I pick. So I might as well just pick one. I can just call the hill. I can call the hill 1 mile, or I can call the hill a half a mile, or better, I can call it a number that's easy to work with. Like like I'm told that I go up at 40 miles an hour and I go down at 60. So, so I guess I'll turn it to you. What might, if I just want to think, oh, I'm looking at the chat. I'm sorry. I think I missed something in the chat, but I'm going to ask you guys, if you had to make up a size of the hill that was particularly easy and convenient. Oh, cool. Miles per hour. Right. Okay. So I'm turning it to you now. If anybody wants to, you don't have to turn on your videos or anything like that. But if anybody's still paying attention with me, what, and by the way, again, please know that I know that you know, like I know you did this already, which I'm psyched. I think this is a very good class. Like you did your, and I think you got it back. So I know you know the answers or whatever, but okay. Cool. I see at least one thing in the chat, and it is public. Thank you. And by the way, the thing that Daniel just very publicly put, oh, and then videos are going, this is great. Oh, the excitement is mounting. Okay. Since the thing that Daniel just put in the chat, by the way, if I, not only, of course, can he submit that for the 50 points of the day, whatever, but he should also double dip that into the assignment that's like for right or for wrong, whatever it's called, the game, right? Because he just totally said something that was either right or wrong. I mean, it was a very concrete, gutsy thing to say. For this case, I think it's right. I'm asking everybody, but I might use a different number myself, actually. So that's a polite way of saying right, maybe not the one I was looking for. I'm going to say to everybody, you can literally, and this is physics thinking now, like you know how to do math. Math is not actually the scary part of physics. The scary part of physics is knowing how and when and why to use the math. The physics part is the logic of saying, okay, wait, apparently, I'm not sure, but apparently I believe that no matter what hill size I make up, I can get an answer. And it's like, that's a very weird thing, by the way, because if you don't make up a hill size, we can't get an answer. But if you do make up a hill size, I think we can get an answer. And in fact, I think it won't matter what hill size we make up, as long as we make up one to work with. It's like weird that that could work. But if this was, but the best thing about it is you don't have to believe me that it can work. All you have to do is try it and try a couple of numbers and you'll see. So it's like worth even trying the minute you even get the thought in your head. So I can try any hill size I want. So I'll choose wisely. This is how physics works. This is what you're going to see in the train of thought assignment that you did when we have that discussion. What physics is about is making these choices before you even solve the problem, really. You make certain choices to guide your computation so that the computation actually is never actually the hard part. So I'm going to choose here. I like 200. So I heard 200. I mean, I read Daniel wrote 200. 200 is good because it's big and lumpy and I can sort of fit 40 into it very nicely. And I can fit 60 into it sort of nicely. The truth is maybe not so nicely. So I might pick a slightly even more convenient number than 200. But 200 sure is convenient. Like it's a lot more convenient than saying 1 mile. If you say the hill's 1 mile, then suddenly we're doing like, we're going up 1 mile at 40 miles an hour. So that's like, oh, it's going to take us like a 40th of an hour to go up. And what does that even mean? That's like a minute and some change. I'm going to go with like Daniel's instinct and make this hill really big so I can divide miles per hour and stuff into it and get nice, easy to work with numbers. But maybe I'm going to make it even tighter than 200 and say, I'm going to say like a size of, I'll say like 120 miles, or you could even say, or 240 miles. Where am I getting these numbers from? I'm in my mind, I'm taking 60 and 40 and getting their like least common multiple, like 6 times 4 is 24. So 240 evenly divides 60 and it evenly divides 40. And once I realize that, I realize even 120 even does that, right? Like I want a number that will work nicely with 40 and 60, either one of these. So I'll even say, let's say, now I'm just saying this. This is what's weird about physics. I'm literally making up that the hill's 120 miles long, a high, not even because I believe that, but because I believe I can get away with making up a number so that I can solve this problem. And the thing is, all I have to do is believe that that's possible. It might not even be true, but if I try a couple numbers, I'll find out if it's true or not. So that's why I'm doing it. So I'm saying this is like how algebra is born. But okay, so let's say the distance is 120 miles. If I do that now, I can say, okay, go to the definition. The only thing I know is the definition. Average speed for this whole thing is going to equal total distance over total time. I'm also trying to stress here again that I think this all makes sense in English, but the only thing that's clunky about it and annoying to write down is these big English words, right? So that's why we're going to swap them out and have symbols soon to make it even easier to write. But that's all the symbols do. Okay, average speed equals distance over time. That means total. In other words, equals the distance up plus the distance down all over the time up plus time down. Now I should pause there for a second. It's a lot of English words. There's no numbers here, and you could call those things something else if you want, and we will next, but just notice, or I could, instead of distance, I could write D, I suppose, and instead of time, I could write T. But what I'm trying to say is notice it's the average speed for the whole round trip is the total distance over the total time. So it's distance over time, right? It's not distance over time plus distance over time or something like that. Like that's what averaging would be. I'm just saying it's total distance over total time. Now, up until a moment ago, we didn't know what either of those were, but now I've made up numbers, so now I can do it. In other words, according to my numbers, it's going to be 200, well, it's going to be 120 miles, right? That's up plus 120 miles down. That's the total distance. Now, what are the times going to be? Well, these are supposed to be, wait. Now, these times are not going to be the same. I'll start using symbols now. Remember, like if average speed equals distance over time, then it seems that time, well, right? I mean, this is looking slightly clunky because I'm like refusing to use the actual math symbols until the last minute, because basically once I actually use them, I want everybody to appreciate them and not run away from them. But I'm saying here, if speed equals distance over time, then time, if you're just careful about it, time must equal distance over speed, right? I mean, that's really all I'm trying to say. Therefore, I'm saying the average speed for the whole round trip must equal 120 plus 120 all over what? Well, all over 120 over 40 plus 120 over 60. Like, no matter how I wrote is the important thing is, are people with me to that? I want to pause on that step. Like, does everybody understand, even if you wrote it a different way? But, and again, please, I think I can trust this class. Like, hopefully everybody's taking notes on this, even if you already did the homework and you already got it back, like especially if you did it right, but you did it a different way. If you did it a different way, but got the right answer, please do nonetheless write this down, because then that's like why we're here, to learn yet another different way that you might not have thought of, because this might be leading somewhere. If you did it a different way and got the wrong answer, please do, of course, copy this down. If you did it the same way, got the right answer, you should be so psyched that you should be having fun copying it down again. But I want to make sure, no matter how anybody did it, or if they never thought about it before, before I go any further, is everybody cool with, and again, this is all, what I'm really assuming is that a lot of people got this right, but not everybody did it this way. I want everybody to see different ways. Does everybody understand? Like, is everybody cool with this step right here? Actually, I'm going to look in the chat. Okay. That's, yeah. Oh, cool. Oh, cool. Thank you. That's awesome. That's awesome. Thank you, Molly. Thank you, Dorina. Thank you, Asia. Thank you, Luna. Thank you, Sonia. Thank you, Molly. And Daniel. And thank you, Molly. And thank you. And I totally missed a lot in the chat. I'm sorry. Back to Molly, like 4 years ago. Yes, you could pick any arbitrary number. And I'm glad she's pausing on that and putting that in the chat, or did, even if she gets it by now or whatever. Like, I'm really emphasizing that. That's what I think is weird. Why I want to spend like a whole class talking about this. And this is not a tangent, right? I mean, this is like a homework problem for a reason. I could spend all day talking about this because if there's one thing I'm trying to tell everybody in this room, there's more, there's a million ways to do this problem right. There's a million and one ways to do it wrong. But yeah, one of the possible ways to do this right is to pick any arbitrary number. That is a huge point I'm trying to make. That by the nature, it's not always true in physics that you can just like pick whatever you want, but it's much more frequently true than one would imagine. It is definitely true here that you can pick any arbitrary number, like literally. Let me review this again. So I'm glad someone put in the chat, and I'm not yelling at that. Like I'm sure that person, Molly, totally gets this. But I'm saying to everybody, it is a weird thing. This is a science class where I'm saying the way to solve a problem is to make up some crap and go with it. That's much more true in science than it would often seem, and certainly in physics. Here we're literally realizing that we could make any number up at all as the hill distance and use that number to solve. Even weirder, we're saying the reason you think you can't solve is because you don't have the distance of the hill. Like the reason that people won't just write down the definition, average speed equals total distance over total time. The reason people will make up other methods like averaging the two numbers is because it seems like the one block to solving this problem is lack of hill distance. What I'm saying is bizarrely, that ends up meaning you could make up any hill distance you want. And if you don't believe me, like try. That's why we're trying right now. I'm not even telling you to believe me. I'm saying this is what would happen in my bedroom is I'm trying this idea and I'm going to get an answer. And then I'm going to try a different hill like distance and I'm going to get the same answer. And I'm going to see that there's a reason that this guess is correct, that I can make up any guess I want. It's a really big deal, but even more powerful than that, I'm saying what, and this is the way a lot of physics is going to go. And this really is the purpose of the train of thought problem sheet, or believe it or not, even though that all seems like English. I'm saying even weirder than that is that once you realize, oh, I can make up any hill distance I want and it would still get the right answer, then the true art of physics is going, oh, since I could make up any hill distance I want, what I really should put my effort into is making up a hill distance that makes this problem as easy as possible. If it's really true that any hill distance will yield the truth, what I want is to pick a hill distance that will yield the truth as conveniently and vividly and quickly as possible. So I'm intentionally calling the hill 120 miles. I could have called it 1, and you'll see, I would have gotten the right answer, but it would be like super annoying math. Or I could call it 200, as Daniel like wisely suggested, and I would get the answer a lot more easily than if I called it 1, but I would still get the same answer, you'll see. Or I could call it 120 and I think get the answer about as easily as possible, which is what's happening right here. So this is why I stopped to ask, like, is everybody with me on this circled step, the red step? And it looks like everybody's saying yes, which is great. 100. So yeah, but I picked 100, so I'm just catching up. Yes, yes, yes. Awesome, awesome. Okay, cool. So now if you get where this step came from, and again, oh, and side note, this step is possible because I made up the number 120. It would have worked if I made up any number, like I keep saying, but here's the weird thing. If I don't make up any number at all, I totally can't get to this step. Like that's what's weird about the problem is it's not just that you can make something up, it's that you almost have to. If you don't, it almost seems like you're stuck. But anyway, here I am now, this is
I
like,
have a question.
oh, sorry. Yeah, absolutely. I'm sorry. Yeah,
Sorry.
please, please.
How do we get time from 120 divided by 40? Like, how are we getting the time out of that?
Oh, like what? Okay. Like what the good question. Well, two ways. One is because of the step right before it. Like what I'm kind of saying is I don't know the time. Like you're right. Like we need the time for time up. Let's say we don't know the time up. But if I think about it logically, if I believe that speed equals distance divided by time, then I can rearrange that. It all depends. As long as I have two things known, I can solve for the third unknown thing. Like if I know that speed is distance divided by time, imagine for a minute that I know the speed and I know the distance, which actually is now true here, then I can rearrange that and get the time. That is, so what I'm trying to say here is if speed equals distance divided by time, then multiply both sides of that by time. I could say time times average speed equals distance, then divide both sides by average speed. And I'm saying, oh, time equals distance divided by average speed. In other words, time equals like miles, so to speak, divided by miles per hour, like, which sounds very clunky, but I'll put it in English now. What I'm really saying here is, how do I get the time up the hill? Well, I wouldn't know it, except we're guessing, we're supposing the idea that the hill is 120 miles high. And we were already told at the beginning of the problem that we drive up at 40 miles an hour. So what I'm really saying right here is, what's the time? Well, the time is however much time it would take you to travel 120 miles if you were traveling at 40 miles per hour. So I think it would take you 3 hours. That's what I'm trying to say. Like that the time is the total, it is the distance divided by the speed, since speed is distance divided by time. Does that make any sense?
That makes sense, but I'm just confused on like why would they give us the time of 2 hours in the problem if we didn't have to use it?
Wait, they didn't. I don't think they did. In this problem, they gave you a time of 2 hours. Where do they give you that?
Oh, that's what I have written down, but let me check. I might
Okay, that might be the other. That might be the other the I think in this problem it just says that it goes up at 40 miles per hour and it comes down at 60 miles per hour, and I think and it and I think it doesn't say anything about distances or times, unless maybe someone else. Am I crazy? Does that sound right?
Yeah, I don't see any time.
Okay.
I must have been looking at like another question while
All right.
doing it. I'm sorry.
No problem. No, I'm glad. And look, again, to everybody, this is worth stopping on, because this is also like our kind of our introduction to, like, this always happens in physics with everybody. Like, I'm trying to break this down and explain how it makes sense, because like I think it does, right? And I like physics. So I think it makes sense once after I say it. But if I say it right enough and I make it sound like it makes enough sense, it can sort of sound to everybody like it's obvious and it always made sense. But I really do think there's something hidden and weird about this problem that doesn't leap out and grab everybody, as like a lot of people want to say. So the only facts we were given this problem is you go up at 40. So I'm talking to everybody now. This is totally like not like Luna's thing or anything, but just to review where we are, we're told we went up at 40 and we're coming down at 60, the same hill. What's our average speed? And if someone just walked up to me and that's literally the whole problem, like literally, if someone just walked up to me on the street and just said it, they could say it like that. A dude goes up a hill at 40 miles an hour, comes down the same hill at 60 miles an hour, and like nothing else happens. Like, he takes barely any time to turn around, blah, blah, and he doesn't take bathroom breaks. So he goes up at 40, comes down at 60. What's the dude's average speed? Now, I'm a physicist or whatever. I'm a physics professor. If someone just walked up to me and said that, I would be very liable to be like, 50, get out of my face, right? It really seems instinctively clear. It goes up at 40, down at 60, same hill. What's the average speed? What I'm trying to tell everybody in the class, like everybody, is if even for one moment you're thinking in your brain 50, then you are paying attention and you're with me, like, and you're in the right place in the right class, like something. And if you're not seeing 50 at all, then I'm not sure you're actually paying attention, whoever you are. Like, and I'm not looking at anybody. I'm just saying this. Like, but realize the whole problem is meant to be very simple, not easy, but simple. Woman goes up at 40, she comes down at 60, same hill, up and down. That's all we know. Up at 40, down at 60. What's her average speed? And what I'm saying is, if you think it all in your mind 50, then don't be ashamed of yourself at all. Don't think I'm shaming you. Don't think you're in the wrong place, and don't skip by that thought either. Don't be like, oh, but I know that's the wrong answer, so like, let me listen to the right thing. No. Like, there's a reason everybody wants to think it's 50, and you should dwell in that space for a bit. Like, but what I'm saying is, actually, if we're very careful and we actually embrace, like, the key to the problem, the reason everybody wants to go 50 is because they're not given a distance to work with. So they just slam speeds together. That's everybody's instinct, that you're told two speeds, you're not told anything else. Even though speed is distance over time, since you're not told anything about distances, it's instinctive to just smash the speeds together. What I'm saying here is, whoa, since we're not told the distances, that's very important about the problem. The fact that we're not told the distance must say something actually about the role of distance in this problem. I can't get around it, because average speed is distance over time, no matter what. That's its definition. So the distances were hidden in this problem. But if I do this weirdo math, what I'm ultimately saying, and it's one way of doing it is this weirdo math of, if I'm saying, wait, that I mean, the logic is, again, distances were not told to me, but average speed is distance over time. So there must be a way to do this while working around the distance. I'll make up a distance and see what happens. Now, again, I don't know what's going to happen, but I made up a distance that's easy to work with. Put another way also, if I don't know what's going to happen, if I'm just making up a distance just to try something, like maybe I do believe that the distance matters. Maybe I believe I miscopied the problem or something, but I've got to try something. So I try with a distance that I can use, like 120. Just like if you're going to look for your missing contact lens, if you really have no idea where in the room your missing contact lenses, at least start with where the lighting is good, if you know what I'm saying, right? I mean, at least first look in a place that you're not going to bang your head in the wall where you're looking, and hope it. So that's what I'm doing. I plugged in 120 here. I get down to this step that I just circled, this step, and it looks like a big mess of clunky math. But there's a couple things I can do. I can try to clean up the math by following math rules and realizing, oh, I've got two fractions here that have different denominators. I would need to add them. I got to get the common denominator. I could do all that. Or I could realize I could factor out a 120 from the top and the bottom. So that's what I'm going to do. I'm going to go to the next page and factor the 120 out. And again, especially even if you got the right answer, if you didn't do it this way, just for kicks and giggles, please do copy this down. So I'm saying average speed equals, we said 120 plus 120 over. And hopefully, and this does look, this does look more complicated than I want anything to look, but hopefully if you see where every piece came from, you see why it's at least true. Now I want to make it simple just like you do. So I'll factor out a 120 from the top. And I can factor out a 120 from the bottom as well. Right, it's starting to look a little bit more reasonable now, a little bit, right? So what do I have? And again, I'm going through this to make a point. Now, you wouldn't necessarily do all this on every single problem that you ever face in physics. But now 140 plus 160, well, I do have to, these are two fractions. I do have to add them together. You know, they do have different denominators. So I know people don't like, but this is where the common denominator comes in again, not coincidentally. Like, I hope this is, you can stop me, but this is what I'm going to do. This is how I get a common denominator. Like, I don't know if that's skipping a step, but I hope people, in other words, I multiplied. I'll show you. This is what I did in order so that now I can add them. Right now, this is a lot of work. And again, I'm really trying to say there's a lot of math in physics, but believe me, what most of physics is an attempt to try to keep the math simpler. It's not because we want to do more math, and it won't always look like all this computation, but look what's happening though. Maybe you'll see what's happening. I'll just copy this in the next page. Sorry, just looking at it. I'm just making sure yeah, okay. So that's just a recopy of the last page. I'm just trying to do this necessarily. Okay. Yeah. There's a couple things I want to say about this. Again, this looks like a long, clunky way to do it. This is not the only way to do it. I'm going to show you another way or two in a second, but a couple things about this way. One thing is, if you think this is long and clunky, I think it's even longer and clunkier if I didn't make up 120, because at least at every step along the way, I had common denominators, and so I don't know if you can see that, but more to the point, look what happened right here. Like, when the 120s canceled out, like what? Like, one thing I want everybody to notice is that 120 that I made up ended up being in the numerator and in the denominator. And it's also a little confusing. It's also in the other fraction, but it's in the numerator and the denominator. It canceled itself out. Like, whatever number would have been there, whatever I made up for the hill actually would have appeared in the numerator and the denominator and canceled itself out. And to be honest, this other 120 right here, this is the common denominator. That is to say, this would have stayed no matter, you could test again if you want, that 120 would stay there no matter what, because it is the lowest common denominator of 40 and 30. Like, it just came from adding those fractions. But I'm saying, number one, if you look closely at all the work we just did, part of the point of doing that work was to show actually that the 120, we needed to do the work, but then it enabled us to do the work, but it dropped out of the work, like revealing that the actual size of the hill doesn't actually matter. In fact, let me go one step further, and whether this is overkill or not, like, so far what I'm trying to show is that the answer to this problem is 48 miles per hour. It's not 50, it's 48. Oh, and I saw in the chat, I'm sorry, yeah, someone said in the chat, I think it might've been that they read in the problem that that the two numbers are 40 and 50. If I'm misremembering the problem, please stop me, I apologize. I think the two numbers in the problem were 40 and 60, not 40 and 50. But by the way, if the two numbers in the problem were 40 and 50, then everything I'm saying here still applies. It's just that what the answer, one might think the answer would be 45, but it totally wouldn't be. And in fact, I don't know if I have the guts to ask this or not, if you want to answer, but you could, if anybody wants to try this in a side margin to see if they're understanding what I'm saying, if the two numbers given were 40 and 50, then similarly, you would not get an answer of 45. You might want to ask yourself, would the correct answer that you would get if you do it the correct way, would it be like lower than 45 or higher than 45? Would it be somewhere between 45 and 50? Or would it be somewhere between 45 and 40? There is an answer to that you can tell based on what we just did here. Maybe I'll get back to this. Oh, okay, cool. That's very honest of you. All right, totally appreciate it. Okay, see, that's so honest. Okay, and I apologize, but again, but for anybody that if you did get the right answer or you're bored, and I don't mean this, like, everybody's always at different levels. So anybody, for whatever reason, if you already see this whole picture, you may want to, on a side margin, ask yourself, if it were 40 and 50, would the proper answer be something like 47 or something like 42? But and I will ask everybody that in a minute when we get done with this. But back to the show, so to speak. Like, again, I'm using a simple problem as like a hammer here to show a couple of things. One, to be very careful, like, it is a trap question in a way. Like, we don't want to believe the answer to this is 50. We do want to recognize what part of our brain would go there. We would be very, very foolhardy to reject 50. Like, I would be a jerk if anybody handed in 50 as an answer to this and like I gave them no credit or something. No, it's a super reasonable stepping place to think 50. But then you also have to realize why 50 is wrong. Like, we cannot, and well, I actually haven't really shown yet why it's really wrong, but that the right instinct is to start with these definitions. Average speed is defined to be distance over time. But then now it looks like I've just taught an entire class trying to show why you should, when in doubt, make up a size of the hill. I am showing that whatever size you make, I think I'm showing that it's true that that would work. Whatever size of hill you would make up should get you the right answer and should enable you to get the right answer. But as science students, as responsible science students, many of you might reasonably be thinking too, like, well, that seems like wacko. Are you now telling me, like, in general, that's the lesson here? You're going to give us like exam problems where the only way we can get it right is if we make crap up? Like, that doesn't seem like science. Well, good point. It may not seem like science. So, like, is there a way to do this problem properly? Like, is there a way to be like, a Boy Scout or a Girl Scout and do this problem without like ever once even supposing anything fictional? Yeah, there is. Sure. And the mere fact when I saw the 120 cancel out is when I realized, oh, I could just do this algebraically, as some of you totally did in the homework, by the way. And some of you who did it in homework might, even some of those people who did it might have made this up in their head, and some might have gotten it from the web. And either way, totally legit. I'm impressed either way. But sure, you could do it. But this is now we're talking about a minority enough of the class that I think this is worth saying to everybody. Well, like, no, we didn't have to make up. We could like, I'm on the one hand trying to show in the beginning of the class, like, you can actually approach this problem hypothetically. You can say, hypothesize a hill of 120 miles. If we hypothesize that, it might not be true, but hypothesize, see what happens. What happens is you get an answer that shows that your hypothesis was just as good as any other. That's interesting, I think. But you don't have to do it that way. You don't have to hypothesize anything. You can just be general. And this is the essence of algebra. You can instead, and it's kind of interesting how like all the videos turned off the minute I started to get, this is where the algebra part comes in. All the videos go. Fascinating. But here's what we could do. We could literally call the size of the hill X, right? Honestly, what I'm trying to show everybody is that that's the same thing as calling it 120. We're just giving it a name that's easy to work with. But somehow it seems more, to many people, it seems more like proper to call something X than 120, because then by calling it X, I'm not even pretending anything. I'm just saying whatever the hill is, I can deal with it as long as I just have a placeholder called X. If I do this, then I would say, literally, we can do this really fast. Right? I mean, this is the key. Like now all that clunk that I wrote before, hopefully people are, if you're still with me, and I know I'm just trying to break down stuff that you already know. I'm not really trying to tell you stuff you don't know. I'm trying to break down stuff you already know and also separate it out from things that seem right, but aren't. So I'm saying all that gobbledygook before comes down to this simple statement, right? Like the average speed for this round trip journey, if the journey is X far, then really it's 2X over X over 40 plus X over 60. Like and this goes to Luna's question from before, like each one of these is just a secret logical way of saying time. And this is really like, and the whole key is that we're saying the one thing we don't know. This whole problem seems like a mess because the key thing, because we feel like we don't know so much, but there's one thing we don't know, the size of the hill. And we do know that the size of the hill up is the same as the size of the hill down. And we do know that time is always related to distance in this very specific way. So we really have a very simple, once you think of it algebraically, then I'll stop. Um, I won't spend the rest of the whole semester on this one freaking problem. Like, I know it's a dead horse at a certain point, but it sort of does blow my mind to see. What I'm trying to show is the simplicity of it. At the end of the day, like the 120 that didn't cancel out, I'm showing here the one, like the x's just cancel out. X is what we call the size of the hill. And the reason we can call it X or 120 or anything is because it cancels out. What's left is that 120, that other 120 that sits there. Like what's left is exactly the numbers that we had over here. Like it ends up being this same, what ends up remaining is that 5/120 or whatever, simply because of the numbers 40 miles an hour and 60 miles an hour. In the end of the day, we just call the hill X, the X cancels out nicely, and we just find that the answer is 2/5/120, which is 48, no matter how you slice it. And here's my last thing to say about that. 48 makes sense to me. The reason the answer is not 50, the reason the answer is slower than 50. Well, actually, I know, I guess I want to ask everybody, like at the end of the day, what we're saying is if you go up 40, if you go up at 40 miles an hour, like on average, which could mean if you want to picture that the whole time you were going 40 miles an hour, and then you come down at 60 miles an hour, we're saying that you average, that your average speed is 48 miles an hour. We're saying, like, no matter how you solve this, if you solve it correctly, we're saying your average is 48, i.e. slower than 50. We're saying that your average is slower than 50, that somehow your average is more, like somehow the 40 that you did on the way up somehow seems to count more in this averaging or be more heavily weighted or something than the 60, because your average in the end, we're saying, is going to point lower than 50. I'm going to pause right there and say, is there anybody in the class that could in any way, in private chat, in public chat with their voice, someone want to explain why it makes actual sense that the final answer is less than 50 rather than equal to or greater than 50? Does anybody want to take a stab at that? And I'll write it in the chat just to wake everyone. Could is if you know what the you don't have to answer the question, but that's very good. And very good. That is definitely 75 points right there. Like definitely, submit that into both class participation and the right wrong thing. So I'm talking about, and I never say the name right, but oh wait, I know there's a Nick. Wait, well, is it the time that the car took to turn around? Very, very good thought. I'm going to say the truth is that's not quite the answer, but that's very close to the answer. The answer absolutely, like, so let me back up on that. We're assuming for this whole problem, we don't know anything about the time that the car took to turn around. We're assuming it's super small compared to any other times in the problem, or it's not given to us, like, or it doesn't count in this whole thing. Like maybe they turned off the clock to turn around and then they turn the clock back on. But we're not actually including the turnaround. But that's a really good thought, because the answer, I think someone just flipped in the chat. The answer does have to do. Yeah. Okay, Catherine. Then therefore what? Like if you put the two answers together that are in the chat, basically it is the answer. Like one, and I'm sorry, I'm always not saying the name right, but but the first answer in the chat is at the time that took the car to turn around. Not quite the time for turnaround, but the answer does have everything to do with time. And then what Catherine's saying is it because it was going 60, going down, like, what about that? I mean, yes, but therefore what? And let me repeat the question to everybody. I was going to ask a second ago. Could everybody, if you understand, you don't have to answer, but can you put a thumbs up or some kind of hand up if you know what the question is? And I'll repeat the question now, but and then put the question is, why is the actual final answer to this problem closer to 40 than it is to 60? Like the answer, the proper answer to this problem is not 50. It's not the midpoint between 40 and 60. The actual answer to this problem is 48. So, and we just did all this math to show that, but I'm asking everybody, why in English does it sort of make sense that the
Is it because the car was going faster at 40 miles per hour?
going faster it was going faster
When it was going up like at 40 miles per hour. So is it closer to 40 because
you're so close. When you almost said it, but when it's going up and going 40, it's not actually going faster, right? It's actually going slower when it's going up, which is weird. I mean, but I know you're saying something right though, you and Catherine, like when it's going, so to everybody, like it went up a hill at 40, but then it came down the same hill, but at 60. So why would we somehow believe that 40 counted more in its average? I'll give everybody a hint. Like a big hint is the word that's in the chat at least once. But remember, speed is distance per time. Speed is distance per time. So I'm not going to tell anybody. I'm going to leave this. Like it goes up a hill at 40 miles an hour. Then it comes down the same hill, but at 60 miles an hour. Somehow we say in the end that on average, it spends its time going like 48. Somehow we're saying that somehow the 40 that it did kind of got weighted into this average more sizably somehow. Like the 40 somehow won out in this averaging over the 60. And it does have to do with what Nikaya is saying. It does have to do with what Catherine's saying. And it does have to do with, oh wait, I'm looking in the chat again, sorry. So close. I mean, but I don't know you're almost there, but I don't know anything about resistance or words like that. Like I don't exactly know what resistance means, but yeah, like, and frankly, I'll give another hint. Even though we're picturing a hill because it makes it easier to picture, anything about this would be true even if it wasn't a hill. Even if you just did a round trip, like you ran from Manhattan to the Bronx 40 miles an hour, and then you ran back from the Bronx to Manhattan at 60 miles an hour, or not ran, but like drove or whatever. Like why it's resistance is getting close, but why would, remember I guess one hit to say is we're saying that for the entire time it took this car to go up and down, for the entire time it was traveling, somehow 48 represents its speed better for the entire time it spent traveling, even though some portion of that time it spent going 40 and some portion it spent going 60. But somehow we think that its whole deal could be better represented by a number that's in the 40s rather than a number that's in the 50s. And it's on the tip of everybody's tongue that's talking. I mean, like Nikaya, Catherine, etc. But what is it about that up trip that makes it count more in the average? Like, put another way, if you guys got, and God forbid this won't happen, but say you got 2 exams in this class and you got a 40 on one exam and a 60 on the other. Okay, I mean that's horrible. Okay, but let's say it's out of 60. I don't know. Then it would be wrong.
is it because the acceleration when it was going back kind of raised the average speed of the 40 miles?
Like that, but it's even less complicated. Like you're onto something, but I don't even know about acceleration or anything because I just have these 2 numbers. But you're right that something made the first trip count more somehow in this average. We're averaging per time. It's not quite acceleration. I know I'm being a jerk here in a way. I mean, I don't mean to be, but if it went slower on the way up, like what everybody's trying to do is come up with some way what's odd is that the slower number I'm saying counted more. 40 is slower than 60, but this average is closer to 40. Why would the slower number sort of count more. Well, I'll give you a hint is if you're going up the same hill as you come down, what do you spend the same amount of time going up the hill as you do going down the hill? So that's a question to everybody. Do you spend, and you can look at I mean, this now goes back to Luna's question early on. Like we didn't know the times originally, but we sort of seem to have figured them out or something about them as we went through. Do you spend the same amount of time going up the hill as you do going down the hill? And if not, which one is? Oh, yes. Oh, I see it now. Oh, right. Oh, and I see it in the chat. I see two people. Why am I so excited? But I am excited. Yeah, right. So, right. So down the hill, when you're going faster, so it seems like good and everything, you're going faster. But when you come down the hill, I'm saying this to everybody, I just saw it in the chat, but to make sure, and again, it doesn't matter if more than one people say the same thing. Like as soon as this occurs to you, like as soon as you get it, feel free to put it in the chat, whatever, and count it for points. It doesn't matter if someone already said it. But when you're going down the hill, what I want everybody to realize is you take less time. It takes less time to go, and not because of acceleration or resistance or any of those other physics things that we will learn about, sure, but I couldn't hold you responsible for right now. Like this is what I want to make clear to everybody. When you're saying things like acceleration or resistance, of course you're thinking like very intelligently. And I don't want to say anything about them as wrong. Like there might be a lot right about whatever you're thinking about acceleration or resistance, but it wouldn't be fair for me to expect the whole class to be able to come up with a reason based on those things, because like we haven't even talked about them yet. Like, so just to be clear, like something about this problem is actually just right there in the basic facts. If you go slower on some trip, you definitely take more time, like assuming it's one distance, right? Even if there's no hill, even if I just go to Chicago and back, if I go to Chicago at a slow speed and I come back from Chicago at a fast speed, then definitely I spend more time going to Chicago than I did coming back from Chicago. And what I'm getting at here is if average speed is ultimately a total distance per total time. If you think about this trip, this car went up at 40, it's going up one hill and coming down the same hill. So it's like crawling up at 40 and then it comes down at 60. Like it goes not quite twice as fast, but like 1.5 times as fast on the way down, i.e. it spends, if it goes down at like 3/2 of the rate, right? Like 60 compared to 40 or 6 compared to 4 or 3 compared to 2, 1.5 compared to 1. Same, if it's coming down at that much faster, it will take that much less time. So what this really is, so what I'm saying to everybody now, the answer to this whole question is 48. The answer is 48. But now what I'm really saying is, because 48 really properly is the average, in this case of 40 and 60, if you take into account time, which we must, because this is physics, like this is about the relationship of space to time. And our definition here of speed is distance per time. So if you take into account, this is what's interesting about the whole problem. And even if we get to nothing else today, and I apologize, but like, to me, this is like worth it. And I do think people are following, especially based on what I just saw in the chat. And I'll open my eyes again and look in a second. But like what we're really saying here is the reason you don't want to just slam together 40 and 60, average them up and get 50 is actually not because we're saying that averages have nothing to do with this. Averages actually have everything to do with this, but we have to be really proper and careful about this average. This is all averages in time. The truth is, so this is no, what time is it? Okay, and we're done in 5 minutes, I know. So we didn't get to train of thought today, and that's my bad. You definitely, I want to take the next 4 minutes to just like wrap this up. But to anybody, first of all, I think you're all participating very well. I do think, and I know you're hanging on because again, I know a lot of you are listening to something that you think you already know, and that's like more annoying sometimes than listening to something, whatever. But I'm going to finish this. We'll start right away with train of thought on Wednesday. You don't have anything new to do. If you have done the 3 sheets, number line, average speed, and even if you think you've gotten things wrong or whatever, don't worry about it. If you've gotten all the 50 points, you're fine. If you didn't get all the points for some reason, you can definitely return anything. And I've proven this now to myself on the Google Classroom. If you resubmit, even if you already got a grade, if you like put in something new, it will make itself clear to me and I'll give you a new grade for it. I mean, you know, if you need to fix something, whatever. But just to finish up this, I just want to say, The last thing I'm saying, just to wrap this up, just to show you how, so average speed is defined to be distance over time. It's not defined to be the average of speeds. But the reason for that is actually because we're respecting averages, not ignoring them. What we're really saying here is, so this is as though you took 5 exams, and again, these numbers are terrible. I apologize. Like, this will never happen to you in this class as long as you're paying attention. But if you took exams in this class, if you got a 40 and a 60, it'd be totally unfair and wrong for me to say that your average is 48. Your average would be 50 for sure. But let's imagine that you got 2 60s and 3 40s, right? If you got 2 60s and 3 40s, then if you really want to count each one once properly, you would have 5 exams, you divide them all by 5, and what you'd see is your average would be 48. It would be like saying 40 times 3 plus 60 times 2, all divided by 5. That's what we would do, right? If you had 5, and that's equivalently what's happening here in this problem. There aren't 5 exam scores, there aren't 5 hours as such, but we don't spend, but we divide the whole time into 5 chunks, 3 of which are spent going up the hill, and 2 of which are spent going down the hill. So it really is an average. It's just a proper average. So that just to show you the nuances of average speed. Next, we'll do train of thought, and we'll move on. I'm sorry. I think you guys have been great. I'm good. If you guys could just say goodbye, or just like unmute and like shout goodbye and leave, or turn on your video and leave, just so I know that we're properly saying goodbye. But
Bye, Professor.
Bye-bye. Thank you very much.
Bye,
Okay.
Professor.
Thank you.
You have a good day.
Bye.
You too. Thank you.
Bye,
Awesome.
Professor.
Bye. Thank you very much.
Bye, Professor. Thank you.
Bye. Thank you. Awesome. Bye. Thank you. Okay. Bye. Thank you. Okay. Bye. I'm looking to chat. Oh, thank you. Bye. Awesome. Oh, and yes, Catherine. Sorry. Right. Right. Okay. Very good. You guys are good. Thank you. Bye. Catherine, I saw what you put in the chat about that. That's awesome. What's in the chat about the homework and the test grades? Yes, I didn't catch it until now, but if you're still here, okay. Oh, thank you. Oh, that's you. Okay, great. Thank you. That's a million points right there to submit and blah, blah, blah. Okay, thank you. Cool. And everybody else is good. You got Yasmin, you're good, or Camilla, Antonio, you guys are good. Because I'm going to shut down in a second because other people are coming for the other class, so I have to blah, blah, the blah, blah. Are you guys good? Okay, well, I'm good. Okay. You guys are good. Or I'm going to say bye. I'm saying goodbye. Goodbye.